कोई ऐसी कोचिंग मिल जाए जो गवर्नमेंट एग्जाम की पूरी तैयारी करा दे। कसम सरकारी नौकरी की मजे ही मजे हैं। एक से बढ़कर एक कोर्सेज मिल रहे हैं, क्लासेस पे क्लासेस चल रहे हैं, सारे सब्जेक्ट पढ़ाए जा रहे हैं। कसम सरकारी नौकरी की मजे ही मजे। इतने प्रैक्टिस क्वेश्चंस की बिल्कुल परफेक्शन आ जाए। स्टडी नोट्स के साथ जम के रिवीजन चल रहा है, एक एक डाउट सॉल्व किया जा रहा है। कसम सरकारी नौकरी की मजे ही मजे हैं। टॉप इंस्टीट्यूट्स तैयारी करा रहे हैं, बेस्ट टीचर गाइडेंस दे रहे हैं, एग्जाम क्रैक करने की रणनीति बन रही है। कसम सरकारी नौकरी की मजे ही मजे हैं। बिल्कुल किफायती दाम, ऑफर पे ऑफर मिल रहे हैं, डिस्काउंट पे डिस्काउंट दिए जा रहे हैं। कसम सरकारी नौकरी की मजे ही मजे हैं। आपकी सरकारी नौकरी की तैयारी को और मजेदार बनाने के लिए सुपर कोचिंग लेकर आया है मजे ही मजे सेल, जहां आपको सभी सुपर कोचिंग पर मिल रहा है अप टू 90% ऑफ और 33% तक की एक्स्ट्रा वैलिडिटी। तो अगर आप इनमें से किसी भी एग्जाम की तैयारी कर रहे हैं तो जाइए, ऑफर का लाभ उठाइए और कीजिए मजे ही मजे।
Hi, good evening everyone. This is Shefali Mam, and in this session we will be talking about insertion and deletion of elements in an AVL tree. So last session में हम लोगों ने discuss किया था AVL tree क्या होता है, what are the different types of problems that can occur while performing the operations on the AVL tree, and then we talked about its solutions. तो आज हम उन प्रॉब्लम्स और सॉल्यूशंस को देखेंगे कि इंसर्शन और डिलीशन करते हुए किस तरीके से वी आर गोइंग टू हैंडल द प्रॉब्लम्स. So for this, directly we'll jump to the question. We'll understand this with the help of one question. So this is the first problem in which we are supposed to create an AVL tree with the given set of elements. So AVL tree is just a binary search tree with a balanced property. So AVL tree is balanced binary search tree. So we'll be adding the elements or deleting the elements from the AVL tree just like we were doing that in the binary search tree. The only thing is, after performing each operation, we need to search for the balance property and will identify the problem. If any problem is coming up, we'll be finding the solution for that problem, like by applying the rotations. Okay, so first of all, when the first element is coming, obviously jab bhi tree ke andar pehla element aata hai, that will be the root element. So here 100 will be the first element of the tree, so 100 will be the root. Obviously, since there is no left child or right child, so there won't be any problem. Balancing factor of the root node or the leaf node is 0 only, because height of left subtree minus height of right subtree is coming out to be 0. Height of left subtree, there is no left subtree, so height is 0. There is no right subtree, so the height is 0, so it comes out to be 0. Anyhow, next, since it's not creating any problem, we have inserted the element. Consider the next element, that is 55. Now, as per binary search tree, 55 is smaller than 100, so it should be a part of the left subtree. So to the left of 100, we'll be adding 55. Is it creating any problem? 55 is a leaf node, so balancing factor is 0. Height of left subtree is 1. Height of right subtree is 0, so it's not creating any problem. That means this tree is balanced binary search tree. Now consider is 0. Balancing factor 2 is not allowed. We know that the maximum difference between the height of the subtrees allowed in the AVL tree is 1. So this means that this is not a balanced binary search tree. So we need to identify the 25. 75 is 75 will be compared with the root element. 75 is smaller than 55. 75 is greater than 55. So go to right side. On right hand side, we are getting 100. Again, the comparison will be done. 75 is smaller than 100. So go to the left side. 75 will be added here. Check for the balancing factors of the nodes. For leaf node, it's 0. For 100, it's 1 minus 0, that is 1. And for 55, it comes out to be height of left subtree is 1, height of right subtree is 2. 1 minus 2 is minus 1, that is also allowed. That means 75 is not creating any problem. Next element, 40. 40 will be compared with the root element. 40 is smaller than 55, go to left side. 40 is greater than 30, go to. We calculate the balancing factors. These two nodes are not connected to each other. Here we had 75. Recalculate the balancing factors. So for leaf node 0, for internal node height of left subtree is 0, 1, and for 55 height of left subtree is 2, height of right subtree is also 2, that comes out to be 0, which is allowed. That means the element 40 is not creating any problem. We have successfully added the element. So are you all getting how we are adding the elements? So we are just adding the elements according to the binary search tree property. The only thing is you need to check the balancing factor after adding each element. So similarly, let's finish the other elements too. Here we are having 85. 85 is compared with the root element 55. 85 is greater, go to right side. 85 is smaller than 100, go to left side. Then 75, so it will be added to the right side of 75. Now need to recalculate the balancing factors according to binary search tree. Element is added, so calculate the balancing factors. Here the balancing factor for the leaf node is there is no left subtree 0, there is a right subtree with the height 1, that comes out to be -1. For 100, height of left subtree, it's 1 and 2. So 2 minus 0, which comes out to tree itself is unbalanced. So definitely pura ka pura tree unbalanced hoga. You need. Still, we are in the middle of the solution, so we cannot rotations apply nahi kiye. Now we need to apply the right rotation. So here I'll be applying the right rotation. राइट रोटेशन ऑन प्रॉब्लमेटिक नोड इटसेल्फ. आप देख सकते हैं अप्लाई कर रहे हैं हम प्रॉब्लमेटिक नोड पे अप्लाई कर रहे हैं. सो आफ्टर अप्लाइंग द राइट रोटेशन हियर विल बी गेटिंग 85 to the left of 85 will be having 75 and to the right we are having 100. Now these three elements will be replaced as 55, 30, 40, and here we are having the elements 85, 75 and 100. Tree is balanced now. I hope that this is clear. 85 is inserted. Next comes the 45. This is the resultant tree. In this tree, I'll be inserting 45. So where should I add this element 45? Check for the element. So the correct location of the elements of 45 is smaller than 55. 45 will be compared with the next element. 45 is greater than 30. Go to right side. 45 is greater than 40, so it will be going to the right side. 45. Check out for the balancing factors. See, if I'm adding the element in the left subtree, that means it is going to make changes in the left subtree. तो इसका मतलब अगर tree unbalanced हुआ होगा या कोई भी problem आई होगी तो वो left subtree में आई होगी. So instead of finding the balancing factor for all the elements, अगर problem आनी है तो always start from the calculation of the balancing factor from the nodes which are added or which is the newly inserted node. So 45 is newly inserted node. So I'll start calculating the balancing factors here. This is 0. For 40, this is left of right subtree is 1. This is allowed. -1 is allowed. For 30, height of left subtree is 0. Height of right subtree is 2. This is not allowed. -2 is not allowed. So the problematic node is 30. Identify the problem. Identify the problem. Problem 30 पे आ रही है कौन सी साइड से? राइट के राइट से. That means on insertion of 45 we are getting the RR problem. RR problem. So the solution for the RR problem is just we need to apply one rotation, that will be the left rotation. So what I'll do is I'll apply a left rotation over this node. So one left rotation is required. After applying the left rotation, let me draw here. After applying the left rotation, we will be getting 40 as the root, 30 will be on the left, so the resultant tree comes out to be 55, 40, 30 on the left, and 45 is on the right. Of right subtree is 0, so that is 1. For 100, height of left subtree is 0 and height of right subtree is the problem. But I want suggest you to follow this approach. Better idea is find out the types of problems. We know that for LL or RR problem only one rotation is required. For L or RL, two rotations are required. So simply identify the problems. किस टाइप की कितनी प्रॉब्लम्स आ रही हैं एंड कितनी रोटेशंस चाहिए. Ultimately that will return the total number of rotations. Okay, let's quickly find out the solution for this one. I need not to construct again the whole tree. Problem consists, that is 100, 105, 102. So I'm just considering this part. And after that, I'll be adjusting it with the resultant balanced tree. Problem is RL problem. So we know that the solution is RL problem. So the solution is, first of all, need to apply the right rotation on the child of problematic node. So here we'll be getting, we are getting here 100, 102, 105. Now, next step is to apply the left rotation, since this is the second rotation and the final rotation. So it will be on the problematic node itself, that is the left rotation. So after applying here 102 to the left, we are getting 100. This is the balanced binary search tree problem. Two rotations are required. So this comes out to be 1 plus 2 plus 1 plus 2. That comes out to be 6. So in total, we have applied 6 rotations to construct an AVL tree from the given set of elements. Is this clear? So this is about inserting the elements in the AVL tree. So according to this, you can try one more question. Try two elements. I'm just considering the tree, final tree. आप अपना answer tally कर सकते हैं, because anyhow on that tree I want to discuss how to perform the deletion. I hope that inserting the elements in the AVL tree is clear to everyone. Next we are going for the concept of the deletion. Okay, so now whatever tree you will be getting from the previous set of elements, that will be 14. To the left of 14, you will be getting 4, 3, and 2. And on the right side, we'll be having 9, 7, and 10. To the right side, I'm taking 21, 15, 18, 28, 26, and 30. So that you will be getting for these set of elements. Now on the resultant tree that we are getting from the previous tree insertions, previous tree elements. Now here I want to delete the elements. First of all, it's saying that delete the element 2. 2 is child. So जब हमने binary search tree की deletion की बात की थी, we talked about 3 cases: deleting a node which is having 0 child, deleting a node having 1 child, deleting a node with 2 children. So here we are trying to delete a node which is having 0 child. So simply you can delete it. Check for the balancing factors. Is it disturbing the tree? Balancing factor is 0, 0, 0. Balancing factor is 1 minus 1, which is 0. For this, balancing factor is height of left subtree is 1, height of right subtree is 2. That comes out to be minus 1, so there is no problem. Anyhow, it is not disturbing the right subtree. So for the left subtree, height is 3, For the right subtree, height is 3, so this tree is balanced. There is no problem. Okay. Now 2 is deleted successfully. Delete the next element 3. Now check for the balancing factors. Is it creating any problem? For 9, it remains same, 0. For 4, now left subtree is over. There is no left subtree element. So this comes out to be 0 minus 2. That comes out to be minus 2. Minus 2 means this is not allowed. So we are getting a problem on the node 4. 4 पे problem आ गई. कौन सी side से problem आई? 3 remains the same. Here we have 21, 15, 18, and here we have the elements 28, 26, and 30. Okay, this is deleted. Now we'll go for the deletion of the next element. Next element is 10. 10 is a node which is having 0 child, so simply I'll delete it and I'll check for the balancing factor. यही चीज हम insertion के time पे करे थे. After inserting every element, check for the deletion. After deleting any element, insertion or deletion के delete factor. So a balancing factor for 7 is 0. Balancing factor for 4 is में कोई changes नहीं आए हैं because right subtree में हमने कुछ किया ही नहीं. So left में we have 15, to the right we have 18. Here we have 28, here we have 20 deleted, that was 10. So on deletion of 10, we are getting here LR problem. Delete the next element, that is 18. From the resultant tree, we'll be deleting the elements. Element is deleted from the right subtree. So we'll be checking for the balancing factors here. It is 0, 0. Height of left subtree, height of right subtree. So it is returning 0. Height of, this is the leaf node. Height of left subtree is replace it with in order successor. Successor predecessor of left subtree is 1. Height of right subtree is 2. So minus 1 is allowed. 7 is not creating any problem. Delete the next element. 3. So concept of insertion and deletion both. Ultimate conclusion is if majority agrees with that,